All right, Mr. Patrick here again. I'm going to talk to you about part 2, square roots. So in the last little video, I introduced the idea of square root is the undoing of a square. It's the opposite operation of a square. And so if I had, and here's the square root sign, it's actually not called a square root sign. It has a really cool name. Well, cool from when I was a kid. It's called a radical sign. Okay, and this little number in the inside is called a Radicand. So that's a pretty cool name for a math symbol, probably the coolest one ever. So radical and radicand. And what this means is we think what two numbers multiply together to get 36. So if I rewrite it over here, the square root of 36 is 6. In other words, we're undoing this square, meaning 6 times 6 is 36. We're undoing that square by doing a square root to get 6. Okay, so we're doing another operation in order to undo that square. These are opposites. Okay, so, and this should be, I guess another way to say that is squared. 6 squared is 36. These operations, squared and square root, are opposites. There is something cool actually, and it's called, with exponents, this square root can continue in exponents. We don't do much of it in grade 8. But for example, if I had something called 2 to the power of 3, that would be 2 times 2 times 2, which would be 8. 2 times 2 is 4, times 2, again, is 8. So this sometimes is called a cube. And the reason this is called a cube, this little 3 up here, is because this is how to find the volume of a cube. If I had length, base, and height all being 2, how I would find the volume, V for volume, is I would multiply, volume would be base times height times length, so I would multiply 2 times 2 times 2. A cube has all 3 dimensions the same. In other words, the volume would be 2 to the power of 3. So they call this a cube because it's how to find the volume of a cube. Okay, and you can actually draw it out if you want it, and actually count the number of cubes that are here. 1, 2, 3, 4. 1, 2, 3, 4, one hidden behind there, and you know that that would be equal to 8. Okay, so this is called a cube. There is something called a cube root, which undoes a cube. So the cube root has a little symbol like this. The cube root of 8 would be 2. Now we don't deal with cube roots until high school, but I thought I'd introduce the idea that you could have a cube root. You could have even a square root of undoing the power of 4. You can undo the power of 5. These numbers can also vary. But in math, grade 8, we don't deal with this at all. We just deal with squares and square roots, not cube roots and not cubes very often. We're mostly just dealing with squares and square roots. So this was just for fun. Okay, you don't need to know this for any test. This is just for fun. Now what you do need to know is how to deal with square roots. Okay, what do I mean with dealing with a square root? Well, there's a little trick, and one of the tricks is that all square roots act like brackets. Okay, so for BEDMAS, we do the brackets first. That's the first thing we do in BEDMAS is the brackets. So here's what I mean when I'm talking about brackets. If I had 80 plus 1, and I'm trying to solve that, what I would do is I would do whatever is underneath the square root first. 80 plus 1 is 81. Then I would solve the square root. Don't solve the square root of 80 and plus the square root of 1. It's not going to work. What you have to do is add these together first and go square root of whatever that number is. And we know the square root of 81 is 9. Here's another example. So if I had 78 plus the square root of 9, that looks really complicated. But if you solve it one step at a time, the square root of 9 is 3. Plus 78, all under a square root. 78 plus 3 is 81. Square root of 81